Hi, I'm Andrew from Alpine Home Air Products. Today we're at the home of someone who's getting a whole house fresh air system installed. Through the course of this video, you'll get to see exactly how you can install your own whole house fresh air system too. It's really not that hard to do, and it's a great benefit to have in your home. Let's get started on this project and go on downstairs in the basement. Okay, here we are in the basement getting ready to install the fresh air intake system. And we're next to our furnace and duct system. Now the fresh air intake system that we'll be installing today, I have right here, consists of a motorized damper as well as a controller. These are the primary parts, and we'll get into the details of how these fit together in just a little bit. But it hooks into a forced air system duct system. So if you have a furnace or an air exchanger, this fresh air system will hook into it to provide that fresh air into your current ducting and distribute it throughout the house. Now, this system incorporates the fresh air into your return air plenum. What do I mean by that? Well, if you look here, we have all kinds of ducts, and you probably will too for your furnace or air handler, wherever it may be. For example, you may have a furnace or air handler in your basement, in your attic, in a crawl space. That's okay, wherever it's at, you can still use the fresh air intake system. But whatever configuration you have, or wherever your system is at, you will still have a supply and return air duct system. It's really quite simple. Let me tell you what I mean. The air flows from each room throughout the home into a return air duct system. It's actually sucked into the return air duct system. It's simply a set of pipes which all come down and funnel back to here. Now the air moves down through here, in through, in this case we have an air cleaner installed, into the bottom of your furnace or air handler, up through the furnace or air handler where it's heated. If you have an air conditioning coil, it'll be up here, it'll be cooled in the summer. And then it goes through this set of pipes. Now this whole set of pipes on this side is called the supply air. And this is where the air blows out. So once the air is heated or cooled, it's distributed throughout the home and blown into each room from the register or vent. That's how a basic air distribution system works in any home that has a forced air system. Knowing that, we now can identify and understand the return air duct. Again, this is where our fresh air intake system is going to hook into. So identify in your system the fresh air intake location, again by identifying first your return air duct system. That's the part where the air is sucked into your furnace or air handler. Now, a tip or trick where you can use to identify if you're not sure which side is the furnace sucking on and which side is it blowing on, look for your air cleaner or air filter. Again, on our system we have an electronic air cleaner here. You might have a disposable filter, but wherever that filter is, that indicates the return air plenum. And again, that return air plenum system is the side that we want to connect into. Did you know that the average person breathes in 3,400 gallons of air per day, and that we spend 90+% of our time indoors? Well, because of that, indoor air quality is extremely important. Now, most homes are not built to have good indoor air quality. However, more and more people are becoming aware of the need to have good indoor air quality and are installing products such as these. In fact, national building codes in a lot of states now require to have a fresh air exchanger to provide fresh air in the home. Why is this important? Well, most homes are built airtight. Now that's good for energy costs, but it's not good for air quality. Why is this? Well, personal cosmetics, paints, plastics, cooking things, hobby items, carpets, they all add up to poor indoor air quality. We can have hundreds of different types of chemicals in the air at any given time which we're breathing, which is not good for our systems. Especially if you have young people in the home or older people, they're more susceptible to the effects of these types of pollutants in the air. Now, outdoor air is typically 10 times more fresh and clean than indoor air. So the way to improve this indoor air quality is to bring in fresh air. Additionally, when there's occupants in the home, they use up the oxygen which is in the air, and they also expel carbon dioxide. So carbon dioxide levels go up, oxygen levels go down. That's not good. How do you fix it? Again, bring in fresh air from the outside into the home. That's what these products do. Now in our installation video today, we're going to be installing this product here by Aprilaire. But I brought two more products with today so you can understand a little bit about other products that are available to do the same job or a similar job of bringing fresh air into your home. Okay, what do we have here? I have a Honeywell fresh air intake system. I have an Aprilaire fresh air intake system and another Aprilaire brand fresh air intake system. And you can see these two are very similar, and this one's a lot bigger. Why is that? Let me explain these two first. Both the Honeywell and Aprilaire systems I have here bring fresh air into the home with a control damper, as well as a control module that regulates the amount of air that comes into the home, how frequently, and for what duration of time. This system over here brings fresh air into the home, but additionally it expels stale air at the same time. Also, it has an energy transfer capability. That means that in the winter time, when you're bringing in cold air and expelling stale air from the home, which is warm, it'll transfer the energy, so it will actually warm up the air from the outdoors as it's coming in. It's about 77% efficient at doing that. Now the same thing happens with this particular system. Again, this is the Aprilaire 8100. In the summertime, when you're running the air conditioner, if you're expelling that cool air outside, the stale home air, and bringing in the fresh air from the outdoors, it'll be hot. It'll transfer the energy between the two, so you'll actually air condition the air coming in automatically. Again, about 77% efficient at doing that with this system. I would then rate these systems as good, better, and best. Today we'll be installing the better system. It's a middle-of-the-road system, fantastic product, and the price difference is pretty significant between the two. These systems each cost around a couple $100 on average. This system here averages around $1,000. So for most people's budgets, often a system like this works out best for them. If only the best will do for you, then this would be the system to have. Let me talk a little bit about the differences between these two systems and why we chose the Aprilaire product today. The Honeywell system does not have an outdoor sensor, whereas the Aprilaire system does. The Aprilaire system decides how much fresh air comes into the home based upon a few factors. One would be ventilation time, ventilation frequency, indoor humidity levels, as well as outdoor temperature. Now the Honeywell system similarly runs according to ventilation time, ventilation frequency, but it does not take into consideration outdoor temperatures. It does, though, take into consideration indoor humidity. So the Aprilaire actually has features that the Honeywell model does not. Because of that, we chose this system today. So let's move along and take a look at what products are needed to install it as far as materials go and as far as tools go. What supplies and materials are needed to install a fresh air system? Here they are. Now all of these items we put together for you to make it easy into our fresh air installation kit. And they include this: a 6-inch round, 25-foot box of insulated flexible ducting, a 6-inch ventilation hood, 2 conductor wire, this is 18 gauge, 50 feet, 7 conductor wire, 20 feet of that, a 6-inch sheet metal collar, 2 different lengths of tie wraps, sheet metal screws, and wire nuts. And these are all included in our fresh air installation kit, which is available online for purchase. Now these two items here, some duct tape and some silver caulk, are not included, which you could provide on your own. What tools do you need to install a ventilation system? These are the tools: a drill bit. I'm using an auger style drill bit, but you don't have to if you have a regular set of drills. A drill chuck. This is going to take sheet metal screws. A 6-inch hole saw. A voltmeter And we're going to use this just to detect the 120 volts to make sure it's off at the furnace. If you don't have one, any type of tester to check for 120 volts will do. A sharp knife, some sheet metal cutters. This type of sheet metal cutter will cut circles, wire strippers, pliers, a couple of screwdrivers. Here's a Phillips, a flathead, and here's a small flathead, a marker, a tape measure, and some safety glasses. Now we want to make sure that your project is safe and that you don't have any problems. So keep a few things in mind, will you please? One, first turn off the power to the furnace or air handler before you begin. Find the power switch and turn it off. Secondly, when working around high voltage, 120 volts, there is the hazard of injury if you're not very careful. Now, if you don't have experience with this or you're not comfortable with it, don't do it. Have an electrician or a heating and air conditioning contractor do this part of the work for you. Another thing to be considerate of is sheet metal can be sharp, so when you're cutting it or handling it, be aware that you could cut yourself if you're not careful. And finally, always follow the manufacturer's installation instructions and specifications. They're provided with the product. This video does not supersede that, so follow the manufacturer's instructions carefully. If you do these things, your project will turn out safely. A fresh air ventilation system really consists of three components: the fresh air vent hood, the ventilation damper, and the ventilation controller. Now, here's the ventilation hood, and it is simply a tube that connects to the outdoors so we can suck in or bring in that fresh air. Now, you're going to have to cut a 6-inch hole to connect this to the outdoors, so you have to find a place in your basement or attic where you can do so. Now, on this installation, I'm going to be drilling the hole here. This is a boarded up window, so it's an easy access for me to cut a 6-inch hole in to get to the outdoors. So this part will sit outside, and this tube will come through and connect to the inside. And it'll look something like this, poking in once that's cut in. So in your installation, you'll have to find some spot, maybe up along here if you were in a basement, if you didn't have a boarded up window, or anywhere that you could access the outdoors. And typically, if you look around, you should be able to find a spot. Again, you can do that from a crawl space or an attic as well. And you'll cut that with a 6-inch hole saw. That will be the first thing that we do. Now, the second part of the fresh air system is the intelligent damper itself. Now, this is a 24-volt motor connected to a precision damper. And it can install in a lot of different places along the pathway from where that 6-inch vent hood comes in to your return air duct system. Now, this is my return air duct system over here. So I can install the damper anywhere along that pathway, which will be conducted by ductwork. I can install it here, I can install it here, and I would simply use strap to connect it into place. So I think what would be convenient for me, since my duct pathway will go from here over to here, is to install it right about here. The third component of a fresh air system is the intelligent controller itself. And this also installs on the return air duct system. So over here, is where I'm going to install it. And it recesses into the duct. So I would cut a hole into the duct and it screws on right there. So to begin with, I'm going to install the vent hood. So we'll get going on that. So here's the other side of the board that we were looking at in the basement, and it's right near a central air conditioner, you can see, but that's okay. Now when you choose the location for your vent hood, you want to make sure that it's not near anywhere where it's going to be sucking in polluted air. So that might be in a parking lot where cars would be running. You also don't want to put it anywhere near a dryer vent so it doesn't suck lint in. And if there was a chimney from a furnace or an exhaust from a furnace, you want to make sure it's not in that area as well. And I can see I don't have any of those in this proximity. and the air conditioner doesn't create any type of fumes, so putting it near the air conditioner will be just fine. So I have my 6-inch hole saw, and I'll drill that hole right now. Excellent, that turned out great. Now I just put the vent hood in place. Great, now I just put a few screws in place, probably in each corner, and then I know it's secured. And we're done out here. I'll also put a little bit of silicone sealant around this to make sure no water gets in. And I put a little silicone on the inside too to make sure no water gets in. The next step is to mount the damper. Where do you mount it? Again, anywhere between where the vent hood comes in and the return air plenum where the system is going to be installed. Now that pathway to me is intersected by the damper, and to me a good place to put it would be right up here on this floor joist. I could install it on the wall if I wanted, but this seems to be a convenient place for me. How do you attach it? With any type of strap. In this case I'm using pipe hanging strap. I'll simply screw into the damper. Now when you screw into the damper, you want to make sure you don't put screws right in the center where the damper will spin, because if you do that, then it would interfere with where the spinning of the damper occurs. So put it more close to the edges of the damper pipe, not near the center. Okay? So we'll go ahead and hang that now. And the other thing you need to know before you hang it is that the airflow is moving from the vent hood to the return damper. So this will be considered upstream, and this will be considered downstream in the movement of air. When you install the damper, put the crimped end downstream, like so. Now that we have the damper mounted, the next step is to cut a hole in the return air duct system and put our collar in so we can attach our ductwork. Now I'm going to install it over here. Where in the return air duct system do you cut the hole? Well, it should always be downstream of the controller, which is also going to be installed in the return air duct system. So I'll put the controller over here, and the duct will enter over here. When installing the controller, which we'll do after we install this collar, make sure again that it's always upstream of where the duct enters the return air duct system. Also, it should be upstream of anything else you have in the system, such as a humidifier or humidifier piping. So I'll go ahead and mark the hole where I'm going to cut the collar in. Now the collar is simply an attachment piece that I put ductwork onto, and it installs in this position. I'll flip it backwards for now, just so I can draw a circle so I know where to cut the hole. And this looks like a good spot, so I'll mark that. And then we put the collar in place. And it's held in by bending the tabs over. Now to install the controller, take the controller cover off first. Do that by pulling the dial knob straight out and then pull the cover off. Like so. And again, we're going to install it upstream here of where we put our collar, so right about here. Now, how large do we cut the hole in the ductwork? Well, inside the installation instructions provided by the manufacturer on page 2 is a template, and it has a little dotted line that if we cut that out, hold it up in place, use our marker, it will give us the exact size hole to cut out of the ductwork. I then drill a hole and cut that out with my sheet metal shears. The next thing we do is install the transformer at the furnace. Now the transformer takes 120 volts and it turns it into 24 volts. The damper runs on 24 volts. Now, where do you install it? You install it wherever there is 120 volts at your furnace or air handler. Typically you're going to find that right at the on-off switch on the side of the unit. And you should see something similar to this. Now, every furnace or air handler should, by code, have a safety on-off switch, and it will be in a box, standard electrical 4x4 box, such as the one you see here. Now, the transformer that's included with the Apeler 8126 fresh air system is designed to hook right into a standard box such as this in one of the side holes. And the two wires that are coming off of it hook up to the 120 volts, which we know is going to be right at the furnace. And then there's two screws on the other side, and that is where we hook up 24 volts to. And I'll show you how to do that in a little bit. But let's go ahead and install the transformer on this 4x4 box. So again, before I start working in here, this has high voltage. You can definitely get hurt on high voltage. It's important to have the power switch not only turned off here, but back at the breaker or circuit panel. Now that's why we have a multimeter as well, so once we open this up we can make sure that there's no power. So again, make sure the power is off not only at the switch, but back at the main circuit breaker or main panel that provides power to this area. We don't want you to get shocked. If you're not sure how to do this type of work, or you're uncertain as to how to proceed around high voltage, don't do it. Have a professional electrician or heating and air conditioning contractor do that. Okay, now I have turned the power off here, so I can go ahead and take this cover off. And inside here, the two wires that come down this pipe, the black and white ones, are providing the 120 volts when the unit is turned on. And inside here, it's simply the other side of the switch and a fuse before the power is run into the furnace. So my transformer is going to hook up to the side of the box. It'll actually be on the outside of the box. And these wires will poke through the side hole, come in, and then we'll hook up the black and white wires, splicing them into the existing wiring. Okay, So there's punch outs on the side of this box. I'm going to go ahead and punch out one of these holes because this is made to sit inside there. And to punch it out, I simply could use a hammer or a screwdriver, push the tab in, then use a pair of pliers, grab it, and pull it out. Now we have a hole in the side there. Once we have that hole, we can stick the transformer in it. Like so. And then tighten the screw down, and it will hold it in place. And the transformer is physically attached to the box. Now we're ready to wire it. Now it's as simple as this. The white wire is going to connect to the white one that's here. So to do that, we're going to have to cut and splice it and use a wire nut to tie all the whites together. And the black one is going to connect to the opposite side of the fuse over here. The reason why is when we turn the switch on and off, I would like the power to also turn off at the transformer. So the whole idea is that we have a continuous 110 volts on these wires, except when I turn the switch off to the furnace, then there won't be. Okay, the first thing I'll do is cut this white wire and strip it. The idea being we're going to connect all these wires together. Good, now I'll use a wire nut and connect all those wires. And make sure that's good and snug. And the white ones are now connected. And then I connect the black one to the other side of the fuse here, since we have a fuse. If there was just an on-off switch without a fuse, I would put it on the other side of the on-off switch. And then put a little bend in the black wire here. And loop it in under the existing screw with the other wire. And tighten it back up. There we go, and it's nice and snug. And lastly, I put the cover back in place. Great, the transformer's installed. Alright, it's time to run some wire. We're going to take the 7-conductor wire and run it from the controller over to the side of the furnace and actually into the furnace to make some connections. So near where that transformer is, that's where the other end of the wire will be, and the other end will start here. Now it's low voltage wiring. It's only going to have about 24 volts on it. So it doesn't have to be running conduit or in any particularly special way. We can simply use our tie wraps provided in the installation kit and tie it to a pipe along this pathway. Now if you had a high voltage wire that was not in a pipe, you wouldn't want to tie it directly to it because there could be some interference electrically. But otherwise, any way that you can secure it, if you had some cable staples, you could use that and staple it to the wood. Or unless your local electrical code says otherwise, this is an appropriate way to do it. So I'm simply going to measure out a length that will get me from point A to point B, strap it in place, and then we can make the electrical connections. And now I want to make sure I have a couple of extra feet to work with, and go ahead and cut the wire. Remember, you can always trim wire, but you can't stretch it, of course. So this will then hook up to the transformer as well as inside the furnace. And I'll show you how to do that now. We'll start the wiring at this end. Okay, we have our 7-conductor wire. Well, maybe we should comment for a second on what is 7-conductor wire. What does that mean? Well, if you look at it, you see there's one big wire. But inside it, close up, there's actually 7 individual wires, or 7 conductors. So when we say 7-conductor, we mean 7 individual wires, and each wire will go to a different place. Now, if you have 8 or 9 or 10 conductors in the wire, that's okay. Simply use 7. The ones that you don't use, you can cut or just twist up or move to the side. But you have to have 7 at this point for this part of the wiring. Also, each of the wires are different colors, but it doesn't make a difference what the colors are. The colors are simply there, so when you hook them up on this end, you can identify them on the other end by the same color. So we get to pick whatever color combinations we want, just as long as we remember on the other end what that color is and what it's connected to. Okay, let's get in up here and take a look at the controller and where each wire goes. Let's take a look at what each of the screws and screw point connections mean here. Now, we have 9 places we could hook wires up to. Where do we hook the wires up? They go under the screws. So we'll start over here. There's this little block, and we can hook up 3 wires to it. 1, 2, 3. And to do that, we would loosen the screw over here to each of them and plug the wire in over here. Okay, that's 3. Now we also have 4, 5, 6, 7, 8, 9 for a total of 9 connections. Now we have 7 wires, and we're not going to put them under all of these points because we're actually going to run 2 more wires in a little bit. One of the wires will go to an outdoor temperature sensor, and the other wire will go to the damper. But most of the wires are hooked up now. You see the sticker up here. The sticker simply explains what these wire connection points are below. So these 3 circles here, one says GS, GH, W, that represents these 3 wire connections, 1, 2, 3 below it. This would be GS, GH, and W. CR represents the one below it here, which is also labeled 24 VAC. Next to it we have DD, which stands for damper, and that also represents the 2 down here, which is also labeled AA, stands for April air. And lastly, there's 2 more that are labeled TT, which is temperature sensor, and below it, it represents these 2 screws. Also, it's imprinted where it says outdoor temperature sensor. So this sticker simply represents the screws. And lastly, there's a little black jumper here. This little black piece of plastic actually pulls on and off of the pins. There's pins here. And that's represented by this little drawing up above. And we'll get to that before we start the unit, but that has to do with cycle time. We can pull this little jumper off, move it to various pins, and that changes the frequency or cycle time that the unit will come on, anywhere from 1 hour up to 4 hours. Okay, so we have a total of 7 wires we're going to connect to these different points. GS, GH, W, C, R, one of the Ds, and then the 7th wire we don't connect to anything. We actually leave hanging here. It'll connect by a wire nut to one of the other wires we bring in later. So that's the 7 wires. Which ones do we connect to which? It doesn't make a difference, believe it or not, as long as we, at the other end, know appropriately which wire is going where. So I simply strip the ends of the wires with my wire stripper about a 1/4 inch back, to take the plastic off and reveal the copper underneath, like so. And then using a small screwdriver, I can connect them one at a time. I'm going to start here at the top and put the orange under GS. And I'll keep just connecting whatever color comes next randomly under each of those 6 screws. I have the red now under GH. I'm going to put the white under W. I'll put the green under C. The blue under R. And the black under one of the D's. There's 2 D's there, it doesn't make a difference which one I hook under. And there we go. And the last one I leave hanging out. And we're all set on this side. Let's go over to the furnace and see where we hook them up over there. First I need to pull off some of the casing that's on the outside here. 5 of the wires that are inside here are going to go inside the furnace and hook up at the control screws and the control wiring. That's the low voltage wiring in the furnace. Also the thermostat is hooked up in that area. And the other 2 are going to hook up at the transformer. So they're all going to start to go their own directions. So I need to take the casing off the outside so I can let them do that. And to do so I could simply use my wire cutters and very lightly drag them. It'll allow me to start to pull that casing right off, and you can see it's starting to come off there. Which of the 7 wires goes where? Well, let's start with the 2 that hook up to the transformer. The ones that hook up to the transformer are the ones that on the other end are the D and the loose wire. In our case, that's the black and the yellow. So I'll take the black and the yellow and hook them up to the transformer. Now they're probably longer than I need, so I'll trim them and strip some of the insulation plastic off the outside and hook them up to either screw on the transformer. And I put a little hook at the end of each wire. Now which one goes where? It doesn't make a difference. You can hook it up on either side. Those 2 are done. 5 more to go. If you haven't noticed by now, this is an old furnace. You might have a newer furnace, or you might have an old furnace too, or an old air handler. Well, if you have one of our new Alpine furnaces, the control wiring is going to be a lot simpler because it's cleaner and all the screws are labeled on a control board, which is placed down here. Now the control board or the control wiring in this furnace is all in here and it looks kind of jumbled together. Most of the connections will be right here at this little block. Nonetheless, although things visually look a bit different between a new Alpine furnace or a different brand furnace or an old furnace, it's still the same concept, and fortunately there's a standardization in furnaces where they use a letter to represent a certain control wire spot. So there's actually letters imprinted on this little control block. Y, G, W, R, and C, which correspond to what the wiring diagram in the Aprilaire installation instructions show. So regardless if it's old or new, we just follow the installation instructions. Let's take a closer look here and see where which wire goes where. Although it looks a little bit confusing at this point, the truth is it's really not. Each of these screws has next to it a letter, and the letter for each screw is C, R, Y, G, and W. Again, if you have a newer furnace, such as an Alpine furnace, all these screws and corresponding letters will be in the lower portion of the furnace. And this is used for control wiring, so all the wires that are connected to it are low voltage, 24 volt wires. And you can see that we have a white and a red and a white and a red. All these little red and white thin wires are hooked up to the thermostat upstairs or the air conditioner, since there's central air conditioner on this furnace in the yard. Now we'll hook up one wire at a time that are already in place at the ventilation control. Starting with our first wire that we put in over there, which was the GS. Now the GS is, in our case, the orange wire. And according to the installation instructions, the orange wire gets hooked up to the thermostat wire that is on G. So this is the G, and there's the thermostat wire that's on the G. So we'll hook that wire and the orange wire together. And it says to take it off where it's at currently and hook it up to whichever wire is on GS. So I'll pull that off, and I'll use a wire nut to connect the two together. And using one of the blue wire nuts provided in the installation kit, snug those two wires together. The next wire on the controller is the GH, and the installation instructions say the GH is connected to the G on the furnace. So again, the G is this one right here, and our GH wire happens to be the red wire. So I'll take the red wire and trim it. It's longer than I need. Strip the end, put a little hook on it so I can get it under that screw. And hook it up to the G terminal and snug that down. That one's done. The next wire on the ventilation controller is the W. And in our case, the W is hooked up to the white. So I'll bring the white around, and the white is hooked up to the W, it turns out, in here. And the W is this screw right there. Trim it, strip it, put a little hook on it, just like the other one. so it will fit under the screw. And put it in place and tighten it down. Great. The next wire is the C, and in our case that is the one that's hooked up to the green. And according to the installation instructions, the C is supposed to go to the C in the furnace, and the C in this case is this screw right here. So I'll leave those existing wires that are there, and I'll add this green one to that. Okay, we've got one wire left. It's the blue wire, and that's hooked up to the R, and the installation instructions say that the R should be connected to the R in the furnace, and the R in the furnace in this case is the screw terminal here. So lastly, I'll cut the wire, strip the insulation, put a little bend on it, and hook it up under the R. And we're all done with the wiring inside here. How are you doing? Did you survive that last wiring? Hopefully you did. Well, the good news is, from here out, it's a lot easier once we've gotten that hard wiring out of the way. What we're going to do now is run 2-conductor wire, which is included in the installation kit, and we're going to run 2 runs of it. One length from the controller to the damper, and then a second length of 2-conductor wire from the controller to the vent hood. And the reason why we're running it to the vent hood is we're going to install on it a temperature sensor. So I'll go ahead and run both of those lengths of wire first, and then we'll hook them up. This is the wire run to the damper, and this is the wire run to the vent hood. I'll go ahead and hook them up in here first. Now, the wire run to the damper, I'll strip the casing off the outside, and it's a 2-conductor wire. I'll cut them to the appropriate length. I'll strip them, take the plastic off. And where do we hook them up? One of the wires goes under where it says AA, also labeled as the second D on the sticker. And the other wire gets hooked up to the loose hanging wire that we already had run over to the furnace, which in this case is our yellow. And the last 2 wires are the easiest probably, and that is the 2 wires that run over to the vent hood, which will connect into the temperature sensor. And they simply go in the last section here, where it says outdoor temperature sensor, or TT on the sticker. And we have a red and white wire, and it does not make a difference which one goes where. So I'll put the red one on the left and the white one on the right, but you could do it either way. control damper, I'll strip back the insulation. Strip the wires and connect either red or white to either of the yellows with my wire nuts. Again, it doesn't make a difference. This is 24 volts AC, and it can go either way. Almost done. Let's go over to the vent hood. Included in the box is a temperature sensor, which we're going to install in the vent hood. So simply drill a hole, put the sensor in the hole, and screw it in place. And then strip and connect the wires together. That would be the wire from the controller and the temperature sensor wire. And again, although we have two different color wires, a red and a white, it does not make a difference which one goes to which wire on the temperature sensor. And lastly, we hook up the ducting between the vent hood and the damper, and then the other side of the damper to the collar on the return duct. And we do that with a 6-inch flexible ducting. You can also use solid duct pipe, which you can obtain at a hardware store, but it does have to be insulated. And the flexible ducting comes pre-insulated, so that's why it's a great idea to use that, and it makes bends simply as well. We'll affix it to the ducts using the long tie wraps, as well as duct tape to keep it in place. Cut into the flex ducting with a sharp knife. And lastly, with a pair of pliers, cut the wire that will separate the two pieces. Roll back the outer plastic vapor barrier. Pull down the insulation, which exposes the inner tube. Slide the tube over the duct. tie wrap it in place. As well as duct tape it at the seam. Put the insulation over the ducting, and then the vapor barrier over the insulation. And lastly, tape it into place. And then I'll do the same thing on the other side of the damper back to the return air duct. And to keep the ducting from drooping, you can put a strap every 5 or 4 feet. If you're going 5 feet or more, you definitely want to put a strap. Ours isn't that long, but to keep it from sagging, I put a strap. If you put a strap on, you can use something like sheet metal or anything else that you like that would create about a 2-inch wide strip, just to keep it from sagging. Congratulations, the installation is done. All we have to do now is adjust 2 simple things. One is this little pin in here, and that's the cycle time. Now the cycle time comes preset at 1 hour. You can go 1, 2, 3, or 4 hours. The cycle time simply means how frequently it will come on. The second adjustment is with this knob. Once we put the cover back on and the knob in place, this allows us to adjust the ventilation time. That means once it comes on, for how long will it come on? So for example, you can have a 1 hour cycle time and a 20-minute ventilation time. In that example, the system would come on once an hour for 20 minutes. Now if we set the cycle time to 2 hours and we kept the knob at 20 minutes of ventilation time, that would mean the system would come on once every 2 hours for 20 minutes, and so on. Now the system will come on and circulate the fresh air into your existing duct system when your furnace or air conditioner is operating, and it's keeping track of when it's operating or not. But suppose it's a nice day and an hour goes by your cycle time, or 2 hours cycle time goes by, and your furnace or air conditioner has not come on, but your system is calling for need to ventilate. It needs that blower to turn on so it can take care of its cycle time ventilation. Well, what will happen is the ventilation controller will automatically turn on the blower in your furnace or air handler for whatever duration of time, whatever that ventilation time is necessary. So in that first example, even if the heat or cooling is not on, it will turn on the blower for 20 minutes of ventilation time once an hour. So you may hear your furnace or air conditioner sound like it's coming on more frequently, but the heat mode or cooling mode may not in fact be coming on. It's just the periodic ventilation and cycle time. Okay, take a closer look at the pins here and this little jumper pin. We can move it off the header pins, and we can move it from 1 hour all the way up to 4 hours. I'm going to keep it in the default position here of 1 hour, but you can see how you can move it by simply pulling it off and sliding it back on the pins. Like so. So now that we're happy with that, we can go ahead and put the cover back on and the knob switch. I've set the ventilation controller at about 20 minutes. Now the system will run based upon outside temperature as well as humidity, so that if it's too cold or too humid, it won't bring in air, and it's really quite intelligent in the way it does that. If it's over 100 degrees, it will not operate. If it's below 0 degrees, it will not operate. If it's below 20 degrees, it will only operate if your heat is already on. It won't just circulate the fan alone. Well, where should you set the ventilation time to? In the installation instructions, there's a little chart which gives some recommendations based upon square footage of the home and how many bedrooms. So for the size home we have here, which is around 2,000 square feet, and with 2 bedrooms, the 20 minutes is a good time. Well, congratulations. You're all done with the installation of your fresh air ventilation system. I hope you enjoy it and that your installation turned out as well as ours. And thanks for shopping at Alpine Home Air Products.